Background is incredible. 6 companies.
I genuinely think this is the next industrial revolution.
Why did you choose stealth strategy?
Rhoda's approach to robotic intelligence is very different.
Few-shot learning. So we can officially call all other robots unimaginative.
We're solving the problem of bringing the intelligent robots into the real world. It doesn't rely on robot data at all.
What do you think motivated him to keep building?
So effectively, you're giving robots imagination.
That's a beautiful way to put it, yeah. What's your kitty's name?
The price they've paid, we study close, reveal what's real, deconstruct, do truths unsealed.
Welcome to another Deconstructed VC podcast. Today we have an amazing guest. Andrew Wooten is a co-founder and chief product officer of Rhoda AI.
And we are very excited because we wanted to talk about that for so many months.
It took so much effort to keep my mouth shut about this company. I was just like, every time people would like, oh, I'm investing in Figure, it's such a cool technology. It's like, I shouldn't say stuff.
We appreciate the sacrifice, Nick.
Yeah.
But now we can.
Finally. Welcome to the podcast. Like
Thank you.
literally, like I'm so glad we got you on the day of the announcement.
So
I hope we can
excited to be here.
edit and make it like polish it and post it as soon as possible because I am dying to ask you all of the questions.
And share all of that answers with all our audience because we're really excited. And today is a special day, as Nick said, that Rhoda AI came out of stealth. And we have a couple of questions like to cover, like blitz questions about the company. So when it was founded?
Yeah, so we started in October 2024. So we think of October 1st, 2024 is our first day.
October 1st, okay.
So
I'll make you a present.
So you've been in stealth for 1.5 years.
Yeah. And you got to have a birthday, so we got to put a pin in it.
How many people in the team?
We're about 50 right now, just over 50.
Very quickly, what the company is doing?
Yeah, so what we're building at Rhoda, actually, I'll start with the problem. The problem we're solving is that of generalist intelligent robots. So I like to think that there's 2 categories of robots in the world. There's factory robots. These are very reliable, very strong, very robust robots, but they just do the exact same motion over and over again, every day, all day for years. And that's very helpful in factories, but most tasks can't be automated that way because most tasks have a little bit of variability. Anything from, the way a box or a package comes in, it's a little bit different every time. Tasks change all the time. So while this group of robotics is very powerful, it's just insufficient to, automate the vast majority of tasks. The second category is what we call intelligent robots. These are robots that leverage neural nets or deep learning. They collect data, and using that data, they can do some variability in their tasks. However, this second category is stuck in labs. So there's a lot of demos on YouTube, Twitter. There's effectively 0 deployments. And even the demos we see, they're very carefully choreographed. So what we're trying to do is we're solving the problem of bringing the intelligent robots into the real world. And that's the mission of Rhoda. We want to create generalist intelligent robots that can accomplish tasks that have never been automated before.
I like that you use the word choreographed demos because like all of the dancing robots, all of the kung fu robots, what do you think about those?
As a product person, I didn't want to dismiss anyone, so I started by studying the TAM for dancing robots, and after a bit of time I realized that it's not a market we should be going after.
It's probably quite small. There should be some market for that though, like belly dance robot.
Could be. I didn't spend enough time in that market to comment.
Where does the name come from?
Yeah, so the name comes from robot data.
Okay.
That's kind of Rhoda got stitched together. It is a bit of a Greenland, Iceland name because we actually use less robot data than any other robotics company out there. But that's where the name came from.
That is really cool. Let's talk a little bit about your personal journey. So you were at Crimson Education, scaling ed tech, chief revenue officer, right?
Yeah, that's right.
How did you get into robotics?
Yeah, so I've always been very excited about technology. I studied computer science back at undergrad, and I've always wanted to work on building new products and creating something that would have a real impact on the world of technology. When I was in my sophomore year of college, I met the Crimson Education founder. His name's Jamie, and he had a very exciting team and growth trajectory. And I really wanted to get practice, building a company. I joined first to, start one of their country offices, but really over time scaled the company internationally. And that was a really exciting experience. But throughout all of my years at Crimson, I always, wanted to be in tech. I knew that the experiences I was building was going to be valuable for, scaling and building companies. And I met some amazing people along the way. But I've always had an itch for developing technology. So when I, finally made it out here to Silicon Valley, I started diving deeper into AI and spending more time, with my now co-founders. Once the opportunity came up to get into robotics, I was really excited to dive into it.
And how did you meet your co-founders?
Yeah, so Eric Chan is our chief scientist, and I've known him since undergrad.
From Stanford?
I went to Yale in US, in Singapore. He went to Yale in the US. And he was visiting our campus, and we got to know each other. And he's a very brilliant guy, also a lot of fun and really humble, just a great guy to be around. So we've stayed friends for coming on 10 years now. And we've wanted to build a startup together, but I've always wanted to do things that were closer to, commercial traction. Mm-hmm. He wanted to do things that were deeper in research. And so I think the moment at which robotics became at the intersection of research and commercial traction around the corner was the right moment. And he shared his idea, his approach with me. Shared a couple papers, and I got really excited about the space. And then he introduced me to Jigdeep, the CEO. Jigdeep has an incredible track record of entrepreneurship, but he is also just a very kind, very humble, very thoughtful person. And I've really enjoyed working with the two of them. And Changjin is also our co-founder.
Jagdeep's background is incredible. 6 companies.
Yeah, this is his 7th.
7th company. So 2 are public. Mm-hmm. 1 got acquired for $1.3 billion by Google, I think.
That's right.
Infinera. He's done incredibly successful deep tech startups, and he still keeps building.
Mm-hmm. What do you think motivates him to keep building?
His answer is he would be doing this even if it was for free. He just loves going from whiteboard to bringing something into the real world. And I think that he's better at that than anyone I've ever met. And I think he's going to keep doing it. And I both feel fortunate to be working with him, but I also think it's great for the world that there's someone with a lot of experience attacking these really big, deep technical problems. In building real commercial solutions. So I'm sure he has decades more of generational company building ahead.
So the technology that you presented today and some of the videos on your YouTube are wild. A lot of folks are showing, robot baristas brewing coffee, but we know they're teleoperated, mm-hmm. Like the one in Tesla Diner. Mm-hmm. Mm-hmm. Some can be semi-autonomous, but very imprecise. But one demo particularly struck me, the one where it's returns processing. Mm-hmm. So I usually see how Marina is one of the drivers of online fashion e-commerce. She orders a lot of stuff and then she returns all of it. So it keeps bugging my mind, mm-hmm. How much actual manual labor there is in processing. Yeah. I think you can break even a robot from just Marina's returns. But that is actually a very hard. I'm sorry.
But I'm keeping this U.S. economy actually.
Yes, she's keeping the U.S. economy alive.
She's keeping us in business at Rhoda, so thank you, Marina.
But so I saw the robot. It unfolds it from mm-hmm. the parcel, whichever way was packed by the actual end user, mm-hmm. customer, which might be completely messed up. Then it has to unfold it, check it from both ways, mm-hmm. and then fold it back. Yeah. Put in a transparent envelope, seal it. Mm-hmm. That is just so much unpredictability. 2 questions. First, how does the robot handle that? Mm-hmm. And maybe you could also do a little dive into the general technology. What makes it possible?
Yeah. Rhoda's approach to robotic intelligence is very different from how everyone's been solving robots. So I would say the conventional approach right now, almost maybe the consensus approach, is something called the vision language action model. And how the vision language action model works is it's a model that's pre-trained with a vision language model, so like a ChatGPT or a Claude, a language that's, a model that's trained on web scale language. And then this model is post-trained with some robot data. So this is how a VLA works. This is how most of robotics is being solved. You have a language model that can maybe observe a scene and say, this is a cup or this is a phone. And then you have people collecting robot data through teleoperation or sometimes through simulation. And the model is being post-trained by that. The problem with this approach is that the entire understanding of physics comes from that robot data set. So understanding of like what an object is, like this is a cup, this is a table, that comes from the pre-training because it knows language. Understanding of how to grasp something and pick it up comes from the narrow robotic data set. And in generative AI, a collected data set is way too small. An example of this is, if you're training a language model, you need to train it on trillions of tokens. You need to download the entire internet to train a language model. But in the world of robotics, there is no pre-training. So everybody's been, collecting their own data for post-training, but they didn't have a solution to pre-training. So, they just plugged a language model in there. What Rhoda is doing different is we're really focusing on the pre-training. We realized that to solve a problem with any kind of generality and reliability, you need to have a strong pre-training prior on motion. Eric's belief is that you can't collect your data to generative AI. You have to go to where the data already is. So what we did is we pre-trained the model on internet scale video data. And once we had that internet scale pre-training, it started to understand physics, understand how things move. And to really just make this practical, the way our robot works is, let's say the job is to pick up this glass. First, it's going to imagine itself in video picking up this glass. So if the arm is here, it'll generate a video of the arm, approaching the glass and closing it. And then once it's generated that video, it then converts that video into actions. And that sounds like a pretty, intuitive approach, but there's a really powerful distinction here, which is the reasoning part, which is thinking about how do I do this task? It doesn't rely on robot data at all. It's relying on the video data that you collected because you're solving the task in video. And what we found is that if you've solved the task in video with very high fidelity, there's only one way you can convert that to action. So there's no reasoning left on the action model. It's purely a translation problem. So essentially, once you've deconstructed the problem this way, robotics becomes a generative video problem instead of a robot problem. And we have a lot of data to solve generative video problems. So that's a little bit about the technique. The big question is, why hasn't anyone done this before? And there's really two main reasons. And they both have to do with video models. One is that video models are generally, most video models you find online, they hallucinate. So even though they can generate a very beautiful image, if you ask it to pick up this glass, it might do something like this, like the arm won't quite close, but the glass will magically lift up. So the physics are just wrong. And the second bit is it's slow. It might take 10 seconds to generate this video. And what we've spent the last 18 months doing at Rhoda, our incredible research team has built technology that both enables a video model that's much faster, so it runs in real time, but not, every couple seconds real time, like literally multiple times per second, generating a video real time. And then secondly, the physical accuracy is to a higher level than any video model out there. So we've built a model that's both very physically accurate and much, much faster. And once you've built this model, you can actually use it to control the robot to do tasks. So that's a little bit of a technical deep dive. Going back to the returns processing a task that you mentioned. If you were going to try to solve that problem with robot data, I don't know how long it would take. It would take an incredibly long time because you need to train every configuration of the package. Oh, hello there.
Hello.
What's your kitty's name?
Emmanuel.
Emmanuel
Cat.
I love that Emmanuel has an interest in deep tech. So you have to, essentially, for this task, you have to, hi Emmanuel.
He requires attention. He's like, okay, can a robot pet a cat?
Yes. This is maybe the
Scratchy.
the are you a human test.
Okay, that's it. You're stuck with me.
But
He
for
likes you.
I like him too. So for this specific task, if you were going to try to train every configuration of where the package is or what clothing item there is, you would have to collect, tens of thousands, maybe hundreds of thousands of hours of robot data. So it's just completely not feasible. But a video model can absolutely generate, especially, an accurate video model can generate a video of opening a package, turning it around, taking out clothing, folding them, inspecting them. So we were able to do that task with, I don't know if we're sharing the exact quantity, but call it no more than a couple tens of hours of robot data. So essentially very, very data efficient.
That's few-shot learning.
Exactly. Yeah, absolutely.
That is wild. So effectively, you're giving robots imagination.
That's a beautiful way to put it. Yeah.
So we can officially call all other robots unimaginative.
I love it. We should have looped you in on the marketing copy.
Thank you. The other question I had. So the robot, during this task, the robot goes through a lot of states that look exactly the same. So I'm inspecting two sides of a t-shirt.
Yeah.
Does it mean I've already inspected the other side? Does it mean that I've already inspected it all and I'm supposed to fold it? If it's folded, did I inspect it? Do I need to unfold it, fold it back? Do I need to seal it? How do you solve the logic? Is it somewhat of an agentic approach?
I think one thing that's very exciting about our model is compared to almost any other robot policy out there is that we have a very long context. So what that means, to kind of break it down, in the same way language models, they have context, how much do they remember of what you previously said? And when ChatGPT first came out, it was very little, and now it remembers your entire chat history. So that context really allows you to reason and execute long horizon tasks. So in the context of robot models, this problem that you're talking about is very real. It's if you have a short context, then if the t-shirt is laying this way, you don't know if it was just put there or if you already inspected it or if where you are in the process, especially if it looks the same. And most VLAs have a context length of maybe 1 to 3 frames, which is a tenth of a second, which of course is not enough to be able to tell the history. Because we're have a very different model architecture, we actually have a much longer context. It's in the hundreds of frames. So our robot actually has a memory of the task as it's doing it, and it's using this memory to reason about the task. And this is a really key distinction because when you don't have context, you usually have to fall back on things like language. So you have to deconstruct a task. If you're doing returns processing, you have to build it into maybe 20 modules. First you do this, then this, then this, and you have either some deterministic or language model walking you through those modules as you execute. Whereas we solve the task through long context, which means when we collect that limited robot data, we collect data on the whole task, and that's enough for it to remember the whole task. We don't need a backbone that's telling it step by step how to do the task.
Similar to our house routine. Now I'm deconstructing all the tasks little ones for you. Maybe should
I have a very short context window. Every time we try to increase it, needle in haystack test is not being passed.
Well, agentic AI is on the rise, so you're in good shape.
Yes, I will use it a lot.
Can we ask? Maybe it's appropriate to ask here. So why did you choose stealth strategy?
Yeah. So. This is really Jigdeep's kind of wisdom coming into the equation. I think I would have defaulted to sharing things earlier on, but I've really liked how we chose to build Rhoda. The way Jigdeep puts it is there's 3 reasons to have a public profile. It's to find investors, find customers, or find team members. Building a business isn't about having your name on the website or seeing your name in the press. It's about creating value. And those are the 3 parties that you need to create value. Our thinking was from the start, if we need to come out of stealth to build more relationships with one of those 3 key audiences, then we will. And if we don't need to come out of stealth, then we won't. So we almost flipped it around and said, at Rhoda, it was always about why come out of stealth. It wasn't about why stay in stealth. And for the first year and a half, through our network and through our researchers' reputation, in the science community and Jigdeep's reputation in the business community, we were able to, both recruit incredible teammates, get really high value, add investors on board, and actually both, our team's network and our investor network has been really helpful in starting those initial customer conversations. But now we feel like we're at a point where the team is getting to a size, and the technology is getting to a maturity where we want to start, accelerating the flywheel, and we want to start building our team faster, and we want to start, building relationships with the customer and investor community faster. So because of that, we chose to come out of stealth.
We actually started discussing that how it was to answer questions about your job.
So we had even when we were in stealth, we all got in a room and said, okay, what are we gonna tell people? Because people want to know what you're working on. They're worried what's going on if you don't talk about your job for too long. So we agreed that we were okay saying we're at the intersection of robotics and AI. So I've just been telling people that I'm working on building robots, and honestly, it's a pretty fun conversation starter.
Do you know how we call Rhoda inside our company?
I think I've heard it's Asimov, right?
Yeah, Project Asimov.
That's a great name. I love it.
We're we had an incident with another portfolio company where a screenshot of our internal system got to the founders, and they're like, how many people can see that? And we're like, we should probably, for stealth mode companies, we should probably come up with project names. And that's why when we invested the first time, we're like, okay, this is going to be Project Asimov because of the R means robot and laws of robotics, which I think having imagination can solve at least a couple of laws, Asimov's laws of robotics. You can imagine that if you hit a person in the head goes boom, and that is a bad outcome. Should not be translated into action, right?
Well, we have lots of systems in place to make sure that one never happens. So that's even pre-imagination, but for sure, yeah.
Do you have that in any heads exploding in the training set?
We tried to avoid any kind of violence even in the internet scale video pre-training. So I have some good filtering mechanisms in there.
How did you collect so much data of manipulating objects, high accuracy? Did you have an external force of people annotating that? Did you do all internally?
Yeah. Oh, this is a great question because Alex Bergman, he's our chief data officer. He's been at the team pretty much from the very beginning, and he single-handedly runs our data collection pipeline. So probably one of the most talented and efficient people I've ever met. I think he's now downloaded hundreds of millions of videos from hundreds of resources, and he has built the entire pipeline of downloading, processing, evaluating, scoring, preparing, chunking for the AI video model, essentially single-handedly. So just an incredible, both researcher and engineer. And I think what from what we've heard, other companies can take 20 or 30 people. Alex, with the help of some AI tools, is just a machine.
It's a 1000x data scientist.
Absolutely.
So thinking about the competitive landscape, there are some big guys like Figure raised a lot of money, Tesla, there's NVIDIA with their Groot, and Physical Intelligence, a bunch of other guys. None of them use your approach. Do you think once and none of their stuff actually works. It does some good things, but nothing's near human performance. Now, since you've announced this quite widely, and all of my X feed is filled with Rhoda, do you think they're gonna start pivoting towards what you're building? Are they gonna be new entrants? Would Google go after the same field since they have YouTube?
Yeah, I think that's a great question. This is definitely a very hot space, and I think the reason is that a lot of folks recognize that this might be the biggest market ever. When you think of how many things are being produced and moved, or how much manual labor there is, the opportunity is just really enormous. And I personally think that the key factors that go into how quickly GDP can grow is how much labor availability you have and how much capital availability you have. And that formula has been the same for the entirety of history. It's about 2/3 labor, 1/3 capital. Yeah. And once you can start to create labor, which is what I think this generation of robotics is going to do, we can see a exponential growth in global GDP and the economy, and consequently in human prosperity. So I genuinely think this is the next industrial revolution. And in the same way the first one bumped long-term GDP growth from 0.2% to 2%, I think this one's going to bump it from maybe 2 to 10. The world's going to be an incredibly interesting and bright place as this technology matures.
It's actually super interesting because it might keep compounding, like because it's only the first layer of robots for human needs, right?
Yeah.
Then there's going to be robots for robot needs. Then there's going to be extraterrestrial robots because like why send humans if we can send like to build a Dyson Sphere or to send starships to another star system, we could just send robots with microbes.
Yeah, I think this is absolutely right. I think people, we focus. We're starting the company by focusing on manufacturing and logistics. And, some folks will ask, well, why manufacturing logistics? Why not home robots or, hotel robots or something? But I think the reality is if you can make a step change impact in how things are made and moved, that's going to permeate into every other part of human society. And you can look at that, once again, going back to the Industrial Revolution. The Industrial Revolution was about the steam engine, which has nothing to do with maybe necessarily things like healthcare or public safety or life expectancy or breakthroughs in other unrelated fields of science. But how it played out was when the Industrial Revolution happened, more money was invested in these fields. Things were produced faster, moved faster, and that GDP growth tailwind just had an enormous impact on human civilization. I think the reason that humans have the life expectancy they do and enjoy the comforts that we do and the quality of healthcare and the quality of culture and art, a lot of that comes from the resources and efficiency that was unlocked by the Industrial Revolution. So I think that manufacturing and logistics might not be where the average person spends a lot of their time thinking about, but inventing a big technological change in those fields is actually going to permeate through every part of humanity, and I think create a really exciting future. And you're right. I think that the timeline to space making real gains in productivity in space is going to be vastly accelerated by robotics.
You know what? That was your dream to travel to the moon. Maybe it would be not you, but the robots.
Yeah, the moon's close. Like, I don't want to go to Mars. I want robots to go to Mars and to build the Dyson Sphere and like to create infrastructure on the moon so I can go there for a vacation.
Yeah, data centers on Mars. It's a good business.
We were just joking that since there's no atmosphere on the moon, you can move energy without any loss, and then you can maybe use the fun part of low gravity. You can build like a large tent with oxygen in it, with atmosphere, and you can give people wings and let them flop them and fly around.
Sounds like a good time.
Yeah, I mean, like that would be my. I hope my.
And we can move Burning there.
Yeah, or that's going to be my assisted living facility, like for a retirement house. Like I'm going to just fly around like an angel.
At least make sure that you will be on the right side of the moon, so I can look at you and wave you.
Okay. Yeah.
Sounds like you're not joining for the trip.
So also thank you. One of the videos you posted is going to help me fall asleep because it's a 90-minute uninterrupted autonomous box decanting. Mm-hmm. And then another one is 2 hours, 40 minutes of container breakdown.
Yep. I was really hoping you would watch the whole thing end to end.
It is impressive. It's like I just scrolled through it for now, but I will watch it. Anyone else in the market can do that.
So there's I would say it's a matrix of task complexity and duration, and I think that I haven't seen a task of that duration, of that complexity shared by anyone. Mm-hmm. There have definitely been videos that were long duration where the task is very repeatable, like maybe picking something up here.
Very slow.
Yeah, like maybe like folding like the same towel over and over and over again, or like moving a parcel from here to here. I've seen videos like that for 20 minutes, an hour, maybe even longer. But yeah, something like opening and unpacking a box with paper, with plastic, with heavy materials, and running that for an hour. I haven't seen anything like that yet. And these videos, they're really important for the robotics community, because if you're doing a demo of a task one time, you can have a very bad policy and do a very impressive task one time. So at this point, it's just not helpful when folks post videos like that. I think long duration videos need to be the norm. I understand that they're not the best Twitter material. But that's okay. People can speed them up. Not everyone has to watch them. A couple experts can watch them and say, I've watched this, it's real. But I feel like every demo should have a video like that.
People are weird. You'll be surprised what they watch for like hours and hours and hours. And like, we put this to a good music, and maybe somebody wants to smoke some pot and just like watch a robot like do its thing for 3 hours.
At least we have to do something when we are relaxing on the moon. Like,
oh yeah, like we'll just do that. But if so right now you're selling like a robot as a service, if I understand it correctly. So if I'm like a potential customer, let's say I watch one of the demos and I was like, that's exactly what I need, or something similar. How do I buy a robot? Like, do you have a pricing strategy?
Yeah. So our website has a request consultation button. One of the reasons we launched is we really wanted to build more partnerships with more customers, and the way we think about it. If you solve 90% of everyone's problem, you don't have a business. You have to solve 100% of a problem for some people. And we're obsessed at Rhoda about learning 100% of the problem so we can then solve 100% of the problem. And the only way to do that is to talk to customers. And that's why we really have valued, even before the robot made its first move, talking to customers, learning about their use cases, and understanding what's a use case that doesn't just make up for a cool project in the corner, but really moves the needle for their business. So for folks that are running, warehouses or factories, or just involved in those processes, whether it's, commercial, industrial, warehousing, or even other, industries we might not be targeting right now, learning about the use cases is really valuable for us. And, we'd absolutely have to partner with them. So I'd highly encourage them to
reach out.
To reach out, yeah.
So I understand that right now about just 1% of industrial operations have been automated by robots that use fixtures and fixed programming. So you're addressing the 99%, but it also has a power law, like a Pareto distribution. There's a long tail of stuff that you won't probably be interested in doing. Would you be open to selling like software as a solution for like longer tail integrators, maybe companies that were like, oh, I'm going to do a robot for specifically doing milkshakes?
Yeah. Essentially how we think about it is right now, I guess, you can always think about building a company vertically or horizontally. The benefits of vertically is you solve the problem end to end, you guarantee that user experience. The benefits of horizontally is, you focus on one component and you can have access through other players. I think at this stage, a lot of the, robotic stack isn't quite there to where, if we posted our model online tomorrow and said, hey, everyone use this, I don't think a lot of the other components are there in enough volume and reliability to produce that experience. So for now, we're really taking, an end-to-end approach where we want to make sure that the first adopters of this technology have really good experiences, that they get technology in their factories and warehouses that solves their problems, is reliable, is safe, is certified. So we're focusing on the full stack right now. That said, as this space matures, which is happening very quickly, we very much intend to go into more of a platform model where our AI model can be used both by other hardware manufacturers and providers, and also folks that have a specific industry that they want to go after and build a vertical integrator or deployment type of company. So we definitely want to enable the future of robotics and automation to come sooner. And to do that, we have to take care of two things. One is make sure that we build real solutions that add credibility to the space instead of just hype. And the other is that when the time is right, we give entrepreneurs and builders the tools to go and create lots of value. And we firmly believe that while we try to get a lot of the world's best brains into Rhoda, the majority of the world's smart people will always not be working at Rhoda. So we'd love to build a system that enables them to create value and help move this technology forward.
I think that's a really good way to look at it, and also promotes pretty good culture, which is a good segue to my next question. So last couple of weeks, we've been hearing a lot of drama around Anthropic, DOW, and OpenAI, undercutting them and just striking the deal for a couple of execs quitting from OpenAI over this use of AI agents for mass surveillance. That is scary, but like as somebody who was born in the Soviet Union, I have no idea, no delusion of privacy. Robots, however, are scary. What do you guys think about like defense tech? Would you explore that? Is this strategic? Because everybody speaks about China. They're a huge bet on robotics. How do you, like as a company, see this?
Yeah, we really see ourselves focusing on kind of manufacturing and logistics for now. We definitely want to make sure that our technology is used to make lives of people better and not cause harm. So internally, we have pretty strong beliefs on not causing harm with our technology, and this is something that we got a lot of alignment on within the team very early on. So we don't see ourselves, we want to avoid implementations, deployments, technologies that can directly cause harm to people.
That is really cool. That goes very well with
our beliefs,
our belief system, our ethics code. You mentioned you have like guardrails against actually causing harm to humans. Can you dive a little bit into how that actually works? Is it like is it in the language model? Is it in the how does a robot know not to harm?
Yeah, so there's lots of layers to it, and you have to have lots of layers. But essentially, without going into all of the details, where you start is around the data. We have to ingest a lot of data to train our model, both a lot of video data and a little bit of robot data. We want to make sure that there's no data that demonstrates harmful scenarios or that could introduce harmful kind of scenarios into the robot's training. So that's stage one. You want to make sure the data coming in is clean from potential things that may generate harm. The second thing is you want to make sure that the video that's being generated is being screened for any kind of harmful behaviors or controls. So you have to have this data input, data output. For things like language instruction, you also have to screen the language instructions. And then even once you've built, a lot of safety into the AI model with, multiple layers of kind of monitoring, both during training and also during inference, you also have to make the hardware safe. The only way to make the system safe is to have redundancy for safety in the hardware. And we're keeping a lot of our hardware efforts under wraps, but some things that we are sharing is that our hardware design is built from the ground up for safety. And there's a couple architectural choices we made that are very different from all of the humanoids out there. One is that we don't want to use legs. We either have mobile bases or stationary systems, and this is because every customer I've spoken to, they want an emergency stop on a system. Everything that moves in a factory has a red button on it that you can push on to stop the machine. And I just don't believe that humanoids on legs, which are a much higher variability system, are going to be excluded from that very reasonable requirement. So our system is on a wheeled base, which means there's a lot of buttons on it that you can push and it'll freeze. And it'll freeze in place. If you're on legs, you might tip over. If your battery dies, you might tip over and maybe harm a person. But if you're on
everything,
if you're on a wheelbase, you can freeze in place, which is a lot safer. The other thing is we built torque sensing into all of our actuators and brakes, and this is really important because we can detect when a human's around the system, and if a human is around the system, then you can limit the upper amount of torque that the robot can exert. So physically, the robot can't harm a person. So we built it from, is the AI model training safe on inputs? Is the AI model safe on outputs? Are the instructions it can receive and training it can receive limited on harmful inputs? And even after you made the AI model safe, you then want to have redundancy on the hardware side to ensure that even if the AI model gives harmful instructions, the hardware is on low-level controls is just blocked from executing them.
That is a really cool approach. That was, I think, a lot of work.
Well, and I want to be transparent where a lot of these systems, we're actively designing, continuing to iterate on. For now, we're very cautious about how the robots are placed and how they're set up. But as we continue to develop these systems, we're very focused on safety and ensuring that these robots can work next to humans without those humans feeling a danger.
That would probably put some limitations on how fast you can deploy. How many systems you want to have live by end of this year?
I don't know if that's a number we're sharing publicly yet, but I would say our goal for this year is to have a small number of robots within a slightly larger number of companies and larger number of use cases. So our hope is to deploy with X amount of customers and have N amount of use cases in each of those customers. Maybe just a couple robots in those use cases. And really the reason is we don't want to start by trying to scale to very large numbers. We want to start by getting into use cases, learning about these environments, hardening our system so that it works in a variety of use cases, and everything from the user experience to the hardware to the AI model performing in all these use cases. And then once we feel that we deliver lots of customer value, then roll out into scale.
And then every customer can grow with other use cases within their facilities and just like more of the same use case.
Yeah,
Absolutely.
maybe we can discuss right now the team. How many people were initially, how many people you have now, maybe deconstruct a little bit like what they're doing, the functions.
Yeah, so when we started, it was Jigdeep, Eric, myself, and Changjin, and Gordon, who's a co-founder and scientific advisor. He's a professor at Stanford. So it started with the five of us, and we were all kind of focused on different things, but we knew that the key hypotheses we need to prove out is, A, can you generate videos that are fast enough and physically accurate enough to control a robot? B, can you use those videos to control a robot in real time? And C, does this scale with compute and video data, as opposed to scale with robot data, which we think just doesn't practically work in the market. So we really focused on proving out those hypotheses, and building a pre-trained video model takes time and resources. So we spent a lot of time building and developing and iterating on that. We spent a lot of time talking to customers to understand what are the use cases that move the needle, and we kind of did these two efforts at the same time. Now the team is much bigger. We're at over, as I mentioned, over 50 people. And I guess the rough breakdown is we have an AI research team. This is the team that does fundamental science in the video model, inverse dynamics model, essentially everything that goes into the AI and robotic intelligence.
Technical staff members.
Exactly, yeah. but even beyond that, there's a research team, there's the robot software team, which is everything from robot real-time controls, low-level controls, to UX and kind of how you think about controlling the robot, giving it instructions.
Is it, but by the way, is this job title specifically for because everybody keeps calling AI researchers and engineers just technical stuff. Elon calls them all engineers. Is it anti-poaching?
No, I don't think that's what it is. This is something that I really respect about our team members and researchers. They don't necessarily care about, they don't like titles and hierarchy. They like to work collaboratively. They like an environment where everyone's in the team and everyone's contributions are valued, and you make sure that you listen to the best ideas in the room as opposed to default to who's more senior or junior in the room. So I actually think that the naming conventions of referring to folks as members of the technical staff is more because of the culture that researchers like and how they like to build and collaborate together, as opposed to trying to keep them from leaving.
From Zuckerberg approaching everyone. So that part is technical staff. How is your GTM built right now? Your product management? Do you have a department or?
Yeah. So there's on the technical side, we haven't covered everyone yet. So there's the AI research team, there's the software team, and there's the hardware team. So those are the three components of the technical team. At Rhoda, we try to be very engineer and scientist first. So we've been very intentional about scaling the engineering teams before scaling the business side of things. But on the business side, we're starting to build the team and have the infrastructure in place to both do things like go to market, efficiently manage our finances and keep our burn low and steady. And then also on the product side, ensure that we have the capacity to talk to a lot of customers, understand their needs, and communicate these needs into how our product is being built and designed. So.
Do you have any open roles, like vacancies right now? So
yeah, absolutely. There's many open roles. I want to make sure this video is always up to date, so I'll just say that there's a careers page on our website that lists all the open roles. But we're always looking for smart, enthusiastic, mission-driven people to join that care about solving this problem. And we think this is probably one of the most exciting problems to work on right now. The way we think about it is there's only going to be, the moment in time where robots can do everything physically that humans can do is going to happen, not once in a decade, not once in our lifetimes, but like once in human history. And I think that the world is going to be before and after, that moment in time. So it's an incredibly impactful and incredibly technically interesting problem to work on. So if that resonates with folks, I would highly encourage them to apply. We try to list our roles, but we're also hiring opportunistically. So if there's a role that doesn't quite fit on the website, I think sending an email anyway and sharing about your background is something that we really encourage. And we have hired people that way.
Are you all in person in Palo Alto?
Yeah, we have a very in-person culture. So
even for robots should also.
All the robots are in person too. I think if you're building hardware, you have to be there. You can't do it over Zoom. So we have a very in-person culture. 5 days a week, and I really.
And today's working from home.
Well, actually, not really. Yeah. So we all work from the office every day, and I think that A, it helps us get more done and communicate better, but B, it just creates an awesome culture. Like a lot of my really good friends, I've made at Rhoda, and it's awesome to come into the office every day and work with like-minded people. I think it's something that during Zoom, everyone kind of went away from working for the office, and there are benefits from remote work, but there's also a lot of great benefits of, especially when you're building something mission-driven and exciting, just being in the room with the people you're doing it with. If folks are tired of working on Zoom and want to get back into the arena, I think we have a great culture for that kind of thing.
And working with robots in person as well.
Yeah,
we just discussed it that there are two trends. Either you're working everyone in person from the office, or either like everyone is remote and there's nothing in between, because something in between is just not working.
Yeah, hybrid is weird. So let's talk a little bit about fundraising.
Okay.
So you announced 450 million. Bloomberg said it's 1.7 billion valuation.
Feel free to comment that.
Yeah, and then I assume that is like 2 of the rounds, even 3 of the rounds combined. Like everything you raised before you came out of stealth, including this like newer, bigger round. How did it? How's the fundraising environment for robotics right now? Was it hard? Was it like always oversubscribed?
Yeah, so there's definitely been a lot of demand for the fundraising, and we've been kind of fortunate to be in a spot where we've had more demand than room in the round, which has enabled us to choose really value-add investors like yourselves.
Thank you.
So there's a lot of demand. I think investors, and I don't want to speak for them, but I'd actually love to hear your perspective on this too. But I think there's 2 kind of conflicting things happening at the same time. On one hand, I think there's now a consensus that this technology is going to create a huge market with a lot of opportunity, and that this opportunity, the timing is right, that it's not, now is the time to be investing in robotics. So there's that, which is a tailwind. And then the other side of it is there's a lot of showmanship and hype in robotics, and it can be difficult.
We won't point fingers.
Yeah, it can be difficult to tell, the credible, real stories from the hype that's not going to stick around, that's not going to, create value. So I think that when speaking to investors, this is a trend that everyone, we've seen battle with. And to their credit, I think a lot of the best investors have identified this situation, that on one hand, it's a huge opportunity. On the other hand, there's a lot of, bubbly companies that are probably going to go to zero. And I think that they've used that as a reason to get really technical. And I've seen, I've interacted with a lot of investors who have read a lot of the, scientific papers in the space, and who have spoken with researchers in the space. And they know that you can't just rely on reference checks. You have to dig deeper into the technology, understand it for yourself, and choose a play that's really credible. And I think that, to their credit, a lot of the investors that have joined us have taken the time to understand the technology, have taken the time to understand how it's differentiated and why it's different from the typical VLA approach. And then once they understood that, they already have exceptional understanding of markets and growth and scaling. So to them, the part that we need much less robot data is the trigger point to where they know that this is going to be a different kind of business. It's not going to be stuck in the lab, because if you only need dozens of hours to deploy to a use case, that's a very different kind of go-to-market opportunity than if you need to spend a year preparing for every use case.
When we spent those, I think, first 2 hours in your lab before we invested first time, it was actually painful for me because we worked on very similar approaches back in 2017 for our AI cameras. And we had so many ideas we had that, but we were too early. We didn't have your researchers that are way smarter than us. And also the resources that you applied to it were so I was just looking at all that and it's okay, I knew it's going to work in 2017. I just didn't know when and who's going to make it. Now I do. And so for us, it was a no-brainer. And I think for that exact reason, I only know two types of investors that either don't hadn't known about you or the ones who invested. I really never met an investor who looked at Rhoda and said yeah, that's great, but we would pass.
Well, I appreciate your support, and your experience in particular, enabled you to really understand the vision systems and AI and how these things would play together to solve robotics. So it was great to be speaking the same language with you, even for our first meetings.
Okay, so another question that I had is, if you were a founder who's deeply interested in robotics, without ability to raise 450 billion from scratch in stealth mode, which is, I'd say, rather rare. Let's say you can raise 3 mil seed. Okay. What would you build?
I think at 3 million, there's two strategies you can take. I think one strategy...
Take 3 million and run.
That's maybe with that one it's 3, but I would advise against that one. I think there's two directions you can go in. One is you can focus on one of the specific sub-problems and solve it really well. So, some examples of this is, you can look at the full robot stack and say, what are the parts that are missing? And you can really zoom in. Some examples are, I think as of today, no one has a good hand. We've seen a lot of, cool hands that can do cool motions, but there's a chasm there because the hands that are very dexterous are extremely unreliable. I would be surprised if they last a week in a factory. On the flip side, the hands that are reliable are really mostly grippers and have pretty limited dexterity. Working on hands is an interesting one. Or you can even go deeper and say, well, what about the touch sensing on the fingers? What are the sensors on the hands, or what are the actuators you need in the fingers? So I think if someone's very deeply technical and they want to solve an engineering problem, and they have 3 million to go make an impact, I would choose a component somewhere on the robot stack, somewhere from cameras to actuators to materials to sensors to maybe network processing solutions to cloud inference infrastructure solutions to I think data collection is riskier. If folks want to build a data collection business, they should reach out to us and we'll share what kind of data we think is needed for robotics. But with data at this stage of an AI, all the folks that have spent time building data pipelines for VLAs, I think took a risk, because there's both the risk of, will VLA companies buy this? Yeah. There's the additional risk of, will VLAs even work in the first place?
Plot-based systems, there have been virtual environments, people have been trying lots of stuff that ultimately will probably go in a trash bin.
I agree. I think the simulation engines and the data collection, those are riskier because there's 2 stages of risk to it. Of, will people buy this, and does the approach, you have to bet on an approach that you're building towards. But things like, hardware components or networking software components, those could work. That's a good trend to back.
And something that would probably not become core competence for people who are raising a lot of money and solving the full vertical stack.
Yeah, and there's, ultimately the play might be to get acquired by one of those companies if they're going to verticalize, or to build a business where you sell to, if there are multiple companies that can build robots that work, then you can sell to all of them. So that's one direction, and I would recommend that path for folks that really want to get their hands deep with a engineering problem. And then on the other hand, I think now is actually a good time to start building kind of vertical deployment businesses for robotics. So choose a specific industry, choose a set of use cases, understand these use cases really well, understand what are their certification requirements, what are their safety requirements, what are their use case requirements, KPIs, and start experimenting, with the models and the hardware you can find to start to solve those use cases. Candidly, today, the models and hardware that are open source will probably not enable you to do that successfully to production standards. But I think that is around the corner. Working with Rhoda when we open our platform, or buying hardware off the shelf, I think that's going to reach an inflection point maybe 6 to 12 months from now. So I think it already makes sense to start building companies that are very industry specific, industry deep, vertically integrated. So, and that might be a good business to build for someone who's excited about go-to-market and about deploying robots into the real world and wants to have those customer relationships and see their robots, move and build things. So I think with 3 million in the bank, those are the two categories I would choose from in robotics. Either vertical deployment. If you want to focus on the go-to-market side, there's still going to be a lot of technical challenges to solve there. So plenty of engineering meat to dig into, but more go-to-marketing heavy. And then the other is building components, parts. I think with 3 million, trying to build a full stack AI model to robot is probably.
What's the entry ticket you think's like? Given that they would have to catch up now.
Yeah, I think. I guess it depends how you define full stack. Like in some ways, you can raise a lot of money, like some of the software companies out there, like Skilled Physical Intelligence. They've raised a lot of capital, and yet they're still only focusing on part of the problem, which is the AI model. So in some ways, if you're attacking the foundation model side of it, you can't raise too much money. Like it's going to be an expensive problem to really prosecute. On the hardware side, there's also this really big gap between making a robot that looks good in a lab for a demo and a robot that's hardened enough to work in a factory for 3 years. And if you want it to work hard in a factory for 3 years, you need to, you're gonna have to go through multiple iterations. So it kind of depends on your funding strategy. If you're trying to fund end to end from initial robot design through to large volume manufacturing, you need hundreds of millions of dollars. But if you're gonna do it by first building, a design of a robot or a differentiated actuator, and then raising another round based on that to build the whole robot, then maybe to go into new product introduction manufacturing. Like you can do it kind of stage by stage. With the foundation models, it's harder to do it stage by stage.
Are you already open to acquisition opportunities that, looking at smaller startups, maybe pick up some team, pick up a piece of technology or a value chain that's going to be part of the roadmap?
We have kind of, two general philosophies at Rhoda, which is, even though we've raised capital from a great group of investors, we still have limited resources, right? So we want to spend our limited resources on. I'd say we don't want to spend our limited resources on problems that have already been solved. So if someone's already solved a problem and they've solved it well, we'd rather just partner with them or buy it. On the flip side, if the problem isn't solved, we're never afraid to go after it. If there's a very specific technology in the cameras or the sensors that we just don't see a good solution for, we're not afraid to build it and build out the team to build it. So I'd say we're always opportunistically, looking to solve problems, build differentiation, and do that both through, hiring the best people. And sometimes the most efficient way to hire is to kind of bring on a team. So these are things we're open to. But I would say reach out and we'd love to.
So yeah, guys,
learn more.
If you're working on one of these ideas, reach out to us or to Andrew. Either we would invest or they would acquire you. If we're crypto founders,
maybe both in that order, right?
First we invest and then acquire.
Yeah. First we need to invest, then Rhoda acquires, because we need to get the bigger share of Rhoda. And I also have a few ideas for crypto founders out there. So first of all, you can, as usual, work on a distributed robotic system where basically different parts and screws are distributed across the room, and they somehow work together. There's a robot payment solution, of course. So robots need to be able to afford modding parts, like a marketplace of NFT robot parts that you can modify and look awesome, right? They would need that. I think there's going to be a large market for that.
Yeah,
I'll
investment advice.
I'll keep that off my list for now.
I think I have the last question, but I couldn't not ask it since your experience in Crimson And we've got lots of questions about kids and education and what to do with colleges, especially right now in this constantly changing environment. What would you suggest to high schoolers who are applying right now, who are interested, for example, in computer science?
And also, does what you do at Rhoda eliminate the need for trade schools?
I think for a while we're going to be creating more demand for, interesting manufacturing technician jobs. I don't think we're going to be rolling out trade schools for a while. I think there's, we're targeting kind of the dull, dangerous, and dirty jobs that people don't want to do, that companies struggle to find talent for. And even within that category, the triple D as they call it, there's millions of robots to deploy. So I think for folks that are, high skill, and if anything, if you're in the US, I think robotics is going to create more manufacturing jobs. And what I mean, and I mean that sincerely, because most things in the US you can't manufacture. You can't make shoes in the US, you can't make t-shirts in the US. It's just, from a global competitive framing, it's nearly impossible. It's frankly difficult to make cars in the US. We're able to because of a lot of protectionism from the government, but in an open market, it's very difficult to manufacture things. But with robotics, I think we can actually manufacture anything in the US. And I think that's going to create more jobs in manufacturing and logistics, not less, over time, as more and more things are getting built and made closer to where they're consumed, which is also really good for the climate. I wouldn't rule out trade schools. We have a long ways to go to a robot plumber that can walk into a home and fix a pipe. So I wouldn't be too worried. But I think the world is changing so fast right now that it's difficult to see. It's interesting. It felt 10 years ago like predicting the next 20, 30 years was easy. Like there were a lot of experts that had strong opinions about, here's the trajectory of world peace that we're on, the trajectory of technology. And it feels like every 20, 30 year prediction ends up being incredibly wrong. So I don't want to try to predict what the future is going to look like.
Maybe pipes will just regrow themselves.
Who knows? Yeah, there's some interesting things going on in material science, but I would just say, I think finding the intersection of what you're passionate about and what brings value to other people should really be the focus. I think that.
What's the Japanese name for the three circles? Yeah,
it's what you're good at, what you enjoy doing, and what other people need. I think those are the three. The other advice, I heard, and someone shared this at business school, was that if you ask successful people, do they like what they do? They'll say, yeah, they're very passionate about it. But often they weren't passionate when they started it. They became passionate about it because it's exciting to do something that you're good at. So I think that when discovering, what you're passionate about, you shouldn't just do it from the perspective of, kind of sitting on a couch and thinking, what do I want to do right now? How can I make that a career? You should do it by applying yourself, trying different things, trying to learn, even things that might not appeal to you initially. Like, try building a financial model, try designing, a simple circuit, try coding up an application. Like, apply yourself first, take the hours of effort that it takes to achieve, a basic level of competence. And then if you see that you're good at it, then you'll probably grow into a passion for it. So the general, cliche advice is do something you're passionate about, but I would caveat that with not just a passion of unexplored interests, but a passion that comes from working hard on something and building some skills in it.
I love that advice so much, because I have so many people around who are just trying to find out what they're passionate about, but they're actually in this loop, trying to find it, trying to think about spending a lot of time with coaches and therapists and other people, but actually they have to spend more time trying to do it. And
I have never heard a single example, a single anecdote of somebody who has actually found their passion via talking to a coach or a therapist.
But I know the person who knows what he wanted to do since high school. Actually, when Nick has been asked at school what he wants to do, he said, I want to do...
I want to write business plans and strategies and sell them to companies.
I think a coach or therapist can help get someone, in the mental framing for where they're ready to go and apply themselves. But finding the passion won't come from that conversation. It'll come from applying yourself. So I think, if people struggle to, find the motivation to go and get started, a coach or a therapist can be a great level of support. But the passion won't come from that conversation. It'll come from putting the work in.
Still, the last question. If a high schooler wants to work in robotics, where he or she should apply?
I think there's a lot of incredible schools out there. It depends on kind of the exact area of robotics, but going to a lot of universities actually are building robotics programs. You used to have to choose between computer science or mechanical engineering. Now there's actually more and more robotics majors that'll combine things from computer vision to computer science to actuators, mechanical engineering, electrical engineering. So you can actually build that full stack in a college program now, which is really exciting. I've heard that the programs at Stanford, UC Berkeley, Georgia Tech, CMU, University of Washington are really exceptional. I'm sure there's many others I'm not doing justice by not listing, but I would talk to alumni who went to programs, get their specific advice, and see what programs people have had great experiences with.
I think this was amazing, very interesting. I would actually enjoy rewatching it.
Yeah,
I think we did a great job of
deconstructing
the whole thing, which is a huge topic, and I think we kept a pretty good pace, so people won't have to listen at 2x speed.
And I think we covered a lot of insight because I'm pretty sure that it would be the topic for the next 5 years for sure.
Oh yeah, people gonna keep returning to this.
Awesome, I really enjoyed this conversation, and thank you for your support and helping us build our
Thank you so much. Thank you for letting us be a small part of this journey because, this is very exciting.
Awesome.
And I'm so glad that I can now
talk about it.
tell everyone.
Well, you're already coining great marketing terms for us. So
I had a lot of those in my head, so I'm just sitting there.
Amazing. Well, thank you, Nick. Thank you, Marina.
Thank you.